Hey there, welcome to Agile in a Nutshell. I'm your host, Jonathan Rasmussen. One framework that's very handy for teams when they first get into automated testing is the testing pyramid. The testing pyramid is great because it helps teams get on the same page around how they like to tackle automated testing for their project. It can help by giving them a common language, sharing rules of thumb around when and where to use different kinds of tests, and just generally save teams a lot of time and effort by being clear about what kinds of tests they'd like to write and when. In this episode, we're going to take a look at what the testing pyramid is, the three kinds of tests that make it up, along with some rules of thumb around when to use each kind of test. Let's get started. So here we have a humble login page. How would you go about testing this? Well, if we take the point of view of an end user, you'd probably like to see a test that visits the login page, enters a valid username and password, clicks the sign-in button, and then somehow verifies that we got redirected to the right page after, which is exactly what the user interface test does. User interface, or UI tests, are tests that test the system just like a real live end user would. They mimic the user's interactions in the form of a script. We run that script back in the form of a test, and it basically interacts with the system just like a regular user would. For this example here, written in RSpec, you can see how we visit the login page, fill in the user's name and password, and then click the sign-in button just like a real user would. It's a simple, beautiful test that tests the complete system end to end. That's the UI test. Now we could write another kind of test, very similar to the UI test, only this one wouldn't go through the entire user interface. Instead, it would only call the underlying services that back it up. We call this the integration test. Integration tests, like UI tests, slice through various layers of the application, but in this case, they don't go through the UI. Here, in the case of this web application, the integration tests mimic the HTTP calls the browser would normally make on behalf of the user as they log into the system. So for example, to visit the login page, an integration would send an HTTP GET request to the web server, along with the address of the login page it wants to navigate to. This would effectively load the login page. Then it sends the username and password the user would have normally entered with something called an HTTP post, which would include the user's credentials. It could then follow the successful login to the welcome page, where it could check then for some kind of verification that it ended up in the right place. For example, an HTML header with the word welcome. Very similar test to the UI test, just testing the same functionality in a slightly different way. Now, what about all the other things we could test when it comes to login pages? Things like field length, required fields, and checking for duplicate email addresses. We could write all those tests as UI and integration tests. But low-level details like these are usually better served with a faster, more precise type of test, something we call a unit test. Unit tests are tests developers write to prove to themselves the code they're writing actually works. It enables them to make changes without fear of breaking everything. And they're really what enables teams to make changes to code aggressively. So instead of going end-to-end through the various layers of the application like a UI or integration test would, unit tests are much more local. These are low-level, method-level tests that developers write on their objects, and they usually don't hit the other parts of the system. Now, the interesting question is, out of all these three different types of tests, how do we know when to choose one kind of test over the others? You see, we could have written all these tests at any layer of the application. They would have all worked. And teams that are new to automated testing sometimes go about doing exactly that. Without understanding the trade-offs that each kind of test has, they blindly duplicate these tests at each level of the pyramid. That leads to higher maintenance costs, not to mention duplicated effort and pure waste. This is where the testing pyramid comes in. It's a great way to talk about the various trade-offs we need to make sometimes when writing different kinds of tests, and it gives us some rules of thumb around where and when each type of test could be used. Let's take the UI test, for example. UI tests are fantastic at going end-to-end through the entire application and ensuring that everything's hooked up and working. They're the deepest, most integrated kind of test we can write. And if the UI test works, we can feel pretty good that it's probably going to work in production. But this awesomeness does come with a price. UI tests are very slow. It takes orders of magnitude longer to run a UI test than a unit test, which means once we start to collect a lot of these things, our build times start to get long and our ability to iterate quickly really slows down. They also tend to be very fragile. Changing a user interface often breaks the corresponding UI test, so we have to be very careful about how we go about writing these things and try really hard not to make them overly fragile. So because of their speed and fragility, we tend to use UI tests more sparingly and save them for the really important end-to-end style smoke tests. Integration tests, like UI tests, also test connectivity. But because they don't go through the UI, they're nowhere near slow or fragile. These things are great for testing things like web services and giving us some level of confidence that things are hooked up without paying an exorbitant price. And while they are good at telling us when we have a problem, they unfortunately aren't really that good at telling us where, as it could be anywhere in the system. For low-level precision that tells us exactly where things went wrong, that's where we rely on the unit test. Unit tests are the fastest, most productive form of automated test we've got. These tests are fast, highly efficient, highly precise, and can pinpoint exactly where something fails in the system when a test breaks. They give really rapid feedback, they're very inexpensive, and developers write hundreds of these things all day long when testing their applications. Now, the only downside to the unit tests is they do periodically miss bugs that can sometimes only occur when you hook things up. That's why integration and UI tests are still valuable. But for the bulk of our automating testing efforts, we want to rely on the unit test. And that's why when we bring these various forms of tests together and you start to balance some of the trade-offs we just talked about, that's when you end up with the testing pyramid. The testing pyramid is a model that's become popular over the years because it visually captures some of the trade-offs we face when writing automated tests. We may want to write everything as a UI test, but that would really hurt, as our feedback and ability to iterate quickly would really slow down. So we tend to use UI tests more sparingly. We know, however, that we are going to have integration bugs, so we do need some kind of test that enables us to test that various things are connected and hooked up. That's why we do have integration tests. But usually the fastest and cheapest test we can write is the unit test, which is why we like to do the bulk of our automated testing down there, where the tests are fast and really cheap. Okay, that's it. That's the testing pyramid. To learn more about the testing pyramid and how to write really good UI, integration, and unit tests, check out my new book, The Way of the Web Tester, A Beginner's Guide to the World of Automated Testing. There you'll not only learn how to write great automated tests, you'll learn how the web works, some basics around programming, as well as how to organize your tests so they don't collapse on you when you most need them. All right, that's all for now. See you next time, and happy testing.